So electricity is a flow of electron, and we need to understand this behavior of this flow. So as you have compared this flow of electron with flow of water, so let us one more example where this is a water tank and there is a pipeline we have taken from that to get our water. Okay. So as you know that, so water will flow due to there is the pressure difference. This is in a higher height and this pipeline is a lower height, so water will flow. And to experiment it, what we can do, we can add a tap here, one tap, and here is one more tap, and here is one more tap, and you collect, put a put 3 buckets in the 3 places. So what you'll observe is that this flow of water is more here, this flow will be more, this will be little less, and this will be much lesser. So here, if you observe, is nothing but only as the distance is increasing, your flow rate is automatically coming down. So why it is happening? Because of when water is trying to flow through the pipe, there is a friction of inner wall of the pipe and water. So this inner wall friction with water particle, due to this resistance, it is trying to slow down. So it is slowing down, and that is why less and less water you will get it from this pipe. So if you, same thing happen when through a metal wire, when electron is trying to flow through a metal wire, there is also a internal friction given by those atoms to the electron when electron is trying to move. So there is also resistance. So if this, when it is electron is flowing through that, as this length of wire will it will increase, your flow of electron will also decrease. So that is called resistance. That, so what is resistance? It is a retarding force which is reducing your number of electron. It is flowing through the wire as the wire length is increases. Same way the flow of water comes down. Same way if the wire is more and more and more longer, your flow of electron also will come down. And this opposing force is called the resistance. I have drawn here this flow of electron through a wire. This will not happen, this flow of electron will not happen unless I create the potential difference between this end and this end of the wire. Like if I don't put this water tank in certain height, flow will not happen. If they're in the same level, there will be no flow of water. Same way, to create a flow of electron, we have to create potential difference. So how we create potential difference? So we add a battery to it. This is a symbol of the battery. This is a symbol of the battery. Instead of a drawing battery like this in a circuit, we put battery. Instead of a drawing a battery like this, okay, we represent battery in a circuit like this. So once you connect a battery in a circuit, what will happen? Flow of electron will be there from this positive end of the battery to the negative end, and this is the way arrow we have to put it. Now, if we put, instead of one battery, if you add one more battery, then what will happen? This flow of electron will increase. That you can understand very easily. Instead of 2, if I put 3, there will be more flow of electron will happen through this. So this we say that if we apply more voltage, more current will be there. So their relation is proportional. Means if V increases, if V is increasing, I also will increase. So that means they are called proportional. So if these increase, these will increase. V increase, I will increase. So this law is called Ohm's law. So V, now V proportional to I, we can write V equal to I, and once this proportional term is not there, we put a equal sign, then we have to put one R. The constant term called R. And this constant term, in this case, there is no other parameter than a resistance. So when if V increases, I increase. So same relation hold here. If V increase, I increase. And only one constant term is there in this relation of V and I, that is a R. So this law is called Ohm's law. So if we summarize how it came, flow of electron is given by a potential difference offered by a battery. If we increase number of batteries, your current flow also will increase. That increase of potential difference, that is V, is proportional to I, and that gives V equal to IR, which is called Ohm's law. Same way here, if you put this tank much higher height, your flow also will increase. Like here if you put more height, flow of water will increase. In this case, if you add more number of batteries, your flow of electron will be increased. In case of electricity, this law of relation of voltage and current is represented by V equal to IR, which is called Ohm's law. Now we'll discuss a little more on this Ohm's law. We'll try to understand the characteristics of the electricity in terms of the Ohm's law. So what we have understood is very simply, we can say that potential difference, of course, we are adding more and more batteries. So I increases, that we have terms, and we have given relation as a VIR. So if you see this R is a nothing but the resistance of this through which electron is flowing, because as you know that we discussed, any flow, it could water flow, electron flow, there is a resistance by the medium it is flowing through. So that is given by this resistance. So that means if you increase this length of the wire, say your number of battery same, but now you are increasing this wire. You see that length is increased very much. So electron will try to flow through this long path of wires. Then what will happen? If this resistance is increased, if the resistance is become more, but if the voltage number of battery remains same, then what will happen? This I will decrease. So in a circuit, you can say if voltage remains same, resistance is increased, means length of wire is increased, so your current will come down. So that means in a circuit, there is a, in this point of time, two parameter is controlling your flow of electron or current. This I, current, I. Okay, now let us write this I. We are trying to understand that I is equals V by R. So this relation also shows that if V increase, this increase, I increase. And as R in a denominator, you see that mathematically also it is showing if R increase, your I will decrease. So this is very important thing, that how I depends upon the two parameter in a circuit. One is voltage. If voltage increase, I will increase, current will increase. Voltage increase, current will increase. If resistance increase, your current will decrease, because more resistance means what? Your flow of electron is getting more resistance, so your flow will be less. Current is nothing but a amount of electron it is flowing through the wire. That you remember, current or I is a amount of electron flowing through the wire. If voltage increases, amount of electron, number of electron will flow more. If resistance increases, your number of electron flow will be less. So current is nothing but amount of electron is flowing, or amount of charge is flowing through the wire. That is the relation between your current, voltage, and resistance. So for remembering, always you remember V is offered by the battery, R is offered by this length of wire, and I is a result of when V is applied or voltage is applied in a wire. So hope that this relation between voltage, current, and resistance is clear. Current is only possible, I is only possible if V is there. I is dependent. If V is not there in a circuit, there is a no current flow. The resistance of the circuit is there, but if V is not applied, if the voltage is not applied, no current flow will be there. If you apply more voltage, more current will be there. This is the relation between these three parameters. V is a independent parameter. You have to apply V, then you will get I depends upon the value of R. If you apply V, you certainly get I depending upon value of R. This is the relation between these three parameters, and mathematically that is V equal to IR.